Dear students, good morning. So now we are going to see the second unit in modern wireless communication. So unit 2 deals with cells and duplexing. So the basics of cellular systems is covered in unit 2 of modern wireless communication. So as I said, in Unit 2, first we are going to see about cells and duplexing techniques. So when you are going to study the basics of cells, cellular systems solves the problem of spectral conjunction. So we know spectrum is an important thing which should be used efficiently. So this spectral conjunction can be solved using the cellular concept. And when we are moving to this cellular, we can get high capacity in limited spectrum. This high capacity is achieved by limiting the coverage area of the base station to a small geographical area called cell. So the increase in capacity is demand. This capacity can be achieved by the limited coverage area of each base station in a small geographical area is called as cell. So when I'm saying that a small geographical area, the main thing is the replacement of high power transmitter with high power transmitter can be replaced with low power transmitter. So each base station is allotted to a portion of total channels, and nearby cells are allocated completely different channels. So all available channels are allocated to a small number of neighboring base stations. So that is the important thing in the cellular systems. So the interference between the neighboring base station is minimized by allocating different channels. So likewise, when it is low power, it won't interfere. Also, we are going to allocate different channels so that the interference between the neighboring base stations can be minimized. So now again the interference can be minimized also by using a frequency reuse factor. That is, frequency reuse means frequency reuse is an important factor that is used same frequency which is spatially separated by the in the base station. So the interference between co-channel stations is kept below the acceptable level. And also additional while doing this, additional radio capacity is achieved. So the frequency reuse can increase more number of subscribers into the telecommunication sector. So, spectrum congestion can be reduced with the help of cells, and by using low power transmitter, we can cover more number of geographical area, and the frequency reuse technique. So all these cells, low power or frequency reuse, all these are used in order to improve the capacity of the system. So by doing this, the service providers can improve the efficiency of a cellular network, and also it helps to serve millions of subscribers using a limited radio spectrum. So that's a great advantage. After covering a certain distance, the radio wave will get attenuated and the signals will fall below the point where it cannot no longer be used, or it may cause some interference. So the transmitter transmitting in such a specific frequency range will have only limited coverage area. So beyond this coverage area, the frequency can be reused by another transmitter. So the entire network coverage area will be divided into small cells based on the principles of frequency reuse. So likewise, the interference can be minimized, and also the capacity can be increased. So the main agenda is interference is minimized. At the same time, capacity is increased. So hope you understood this cellular concept. So moving deep into the frequency reuse technique, we will see frequency reuse. So here the design process of selecting and allocating channel groups for all the cellular base stations within a system is called frequency reuse or frequency planning. So here each cell labeled with the same letter uses the same set of frequencies, and it also depends upon the cell shapes. The cell shapes can be either circular, square, triangle and hexagon. But technically hexagonal shell shape is conceptual, and in reality it is an irregular shape. So though we are saying that hexagon is the shape of the cell, so shape of cell is equal to hexagon, but this is an ideal condition. Actually irregular shape is the shape of the cell. So suppose if you are going to use circular, then see if you are drawing circles like this. So these areas are uncovered, and sometimes there is a possibility of interference like this. And if you are going to use triangle like this, so all regions will not get the equal amount of power. The square can also be used, but the square, if you are keeping in center, this capital R is not equal to this R, and hence we are not using. Therefore, the final thing which the standard approved is hexagonal shape. So with this hexagonal shape, you can keep a tower at the center, and hence it will radiate the power equally in all distance. So that is why we are going for hexagon shape of the cell size. Okay, so when I am talking about hexagonal cell shape is conceptual, and it is simplistic model for radio coverage for each base station. As the radiation from the antenna is circular, thus there is a fading on the edges of the triangle and the square, and hence hexagon shape which has lesser fade on the edges compared to that of this triangle and square, we are going for hexagonal shape of the cell. When using a hexagonal shaped cell, the base stations areas are depicted as either being in center of cell or center excited, or on the three edges of the 6 cell vertices. So that is called as edge excited cell. For central excited cell, omnidirectional antennas are used. For edge excited cell, sectorial directional antennas are used. So these different types of antennas will be studied later in this chapter. Okay. So now we will see basic things which is used to understand the frequency reuse. So the design process of selecting or allocating a channel groups for all the cellular base station within a system is called frequency reuse or frequency planning. The frequency reuse distance, the minimum distance between the core channels required to keep the core channel interference below the certain threshold. So as I said, the distance should be maintained properly. Each cellular base station is allocated a group of radio channels to be used within a small geographical area called a cell. The base station of an adjacent cells are assigned a channel group which contains completely different channels than the neighboring cells. So that is why a cluster will have many number of cells like this. and each cell will be named with the alphabet, and which are all the cells are having the same alphabet will be given a same frequency so that it will be reused, and the distance between the cells will be properly maintained so that no interference will occur. So that is why how to locate the co-channel cell. So to find the nearest co-channel, so locating co-channel cell is important concept. So one must do the following. So select one cell, any one cell in the cluster. So you assume to be I, and then you turn 60 degree counterclockwise and move towards J cells. So that is the point to which you can select that particular cell for a reuse technique. Okay. So now we will see about the channel assignment strategies. So channel assignment strategies, CAS. So here frequency reuse schema. The main advantage of using frequency reuse to increase the capacity and minimize the interference. So now when you are coming to this channel assignment strategies, it can be classified into two types. One is fixed channel assignment. Another one is dynamic channel assignment. So when you are talking about fixed channel assignment, each cell is located at a predetermined set of voice channel. Any new call attempt can only be served by the unused channels, and here the cell will be blocked if all the channels are occupied. Okay, in dynamic channel assignment, what will happen? The channels are not allocated to the cells permanently. Allocated based on the request. So only when the request is coming, it will be done. Here it will be permanently dedicated channels will be given, and here based on the request it will be allocated, and hence reduce the likelihood of blocking will be there in dynamic channel assignment, which in turn leads to increase in capacity. So when you are talking about fixed channel assignment, in fixed channel assignment, each cell is assigned a predetermined set of voice channels. Any call attempt within the cell can only be served by the unused channel in the particular cell. If all the channels in the cells are occupied, then the call will be blocked and the user cannot get the service. In variation of fixed channel assignment strategy, a cell can borrow the channels from its neighboring cell if its own channels are fully occupied. So that can also be feasible. Coming to dynamic channel assignment, the voice channels are not allocated to different cells permanently. Each time when a call is requested, when a request is made, the base station requests a channel from the mobile switching center. MSC allocates a channel to the requesting cell using an algorithm that takes into account the likelihood of the future blocking. The reuse distance of the channel should not cause interference. Other parameters like cost will be reduced, reducing the likelihood of blocking and increasing the capacity, and requires the mobile switching center to collect a real-time data on channel occupancy and the traffic distributions on the continuous basis. This dynamic channel assignment is more complex in real time but reduces the likelihood of blocking. Okay. So now we'll see about the handoff So handoff is an important terminology which is used in mobile communication. When a mobile moves into a different cell while conversation is in progress, the mobile switching center automatically transfers a call to a new channel belonging to the new base station is called as handoff. So, handoff operations not only involves identifying a new base station but also requires that the voice and control signals be allocated to a channel with the new base stations. So, handoff must be permanently or performed successfully and as infrequently as possible. For this, system designer must specify an optimum signal level at which to initiate a handoff. Once a particular signal level is specified at a minimum usable signal strength for acceptance of voice quality at a base station receiver, the slightly stronger signal level is used as a threshold by which the handoff is made. So this marginal uh, threshold is given by delta, which is equal to probability the how much amount of handoff and how much amount of minimum usable thing is used. So that will tell us how to set the threshold so that successful and also successfully it has to complete, and also infrequent handoff should occur. So that is the aim of any system designer. So what will happen? This delta cannot be too large or too small. Suppose if it is if delta is large, if it is too large, then what will happen? Unnecessary handoff will be taking place, which is a burden to the mobile switching center. If the delta is too small, if it is too small, then make sufficient time to complete the handoff before a call is lost due to weak signal conditions. So the call drop even can happen. So now when there is an excessive delay by the mobile switching center, when assigning a handoff, the excessive delay may occur during high traffic density due to computational load at the mobile switching center, due to the fact that no channels are available on any of the nearby base stations, and case 2 where the threshold delta is set too small for the handoff time in the system, these type of handoff will occur. So there is another one important term in mobile communication, that is dwell time. See, dwell time is nothing but the time over which a call is maintained within a cell without handoff is called dwell time. That is, the call is maintained continuously within a cell without handoff is called as dwell time. Okay. So next, this handoff is an important topic which everyone must understand. There are many types of hands-off available. That is types of handoff. One is intra cell, intra base station switching center handover. Then another one is inter cell intra handover. Third one is inter cell inter BSC handover, and fourth one is inter MSC handover. So if it is in small, then you can go for intercell, then it is the next layer is intercell intra, then intercell inter BSC will come into picture, then mobile switching center will come into picture. So these are all the different types of handoff which is used. So if the handover is in the intra-cell handover, while the subscriber is handed over to another traffic channel within the same cell, then we can say that intra cell, and if it is taken to a next another cell and handover happens, then intercell intra. And if the base station switching center is also coming to picture for handover, then is called intercell inter basic. And if a mobile switching center is coming to the picture, then it is called as inter MSC handover. So these techniques are important to understand how the handoff is taking place. And the next topic which we have to study is classification. Previously we studied types of thing. Now classification of handoff. This classification of handoff is of two types. One is hard handoff and another one is soft handoff. So hard handoff means it is called as break before make, and this is make before break. So as the name suggests, before handing off to the new cell, if it is break, it is hard handoff, and if after making the handoff, if it is break, then it is called as soft handoff. So this is the basics of cellular systems. So students, I think you can understand